In this session, we'll discuss about the fractional distillation of a crude oil and obtaining different fractions from the crude oil. Crude oil is basically a mixture of a hydrocarbon. Different hydrocarbons are there. So how to obtain or how to separate these hydrocarbons from each other or carry out a fractional distillation, that we'll discuss in this chapter. So some common fuels, fuels which we use coal, we use natural gas, and we use petroleum. These are some examples of the fuels. And the petroleum or the crude oil which we obtain, we can do fractional distillation. This is how fractional distillation of a crude oil is done. How we carry out this fractional distillation? So at the bottom, this is a fractionating column. So at the bottom, a superheated crude oil is there. It's like around 400 degrees centigrade. So around 400 degrees centigrade, a crude oil is a mixture of different hydrocarbons, like different compounds are there. Most of the fractions which we add this to fractionating column, most of them are in a vapor form, gaseous form. The only fraction which is in a liquid state or a semi-solid state or a viscous liquid state, that is known as the residue, and mainly this residue consists of a fragment which we call bitumen. You have to learn the name of the fragment and the position where we obtain these fragments and the use of each fragment. Then what is the purpose of the bitumen? It is used for road carpeting and roofs. Maybe you have seen, like example, for a road carpeting, first they put a viscous liquid at, say they heat this viscous liquid and first they put on the road and then they add a concrete. So because it can stick the concrete together, that's why first a layer of a bitumen, and then on that we put concrete. So bitumen is used as for roads or for roofs. But rest other fractions, because the temperature is so high, the other fractions at this temperature are not in a liquid state, the other fractions are in a gaseous state. So these fractions which are in a gaseous state, they start to rise. And when these fractions are rising, they lose their energy. As a result, when they lose their energy, some of them will condense. So after bitumen, the first fraction which condenses, that is called a fuel oil. What is the purpose of the fuel oil? The fuel oil is used for the fuel for ships or for power stations. Then what happens? The remaining fractions will rise. Then another fraction condenses. After that fuel oil, the fraction which condenses, that is known as a diesel oil. The diesel oil, it is normally used for trucks, lorries, buses. We use like even some diesel engines are there for cars. Most of the loading truck, because the diesel can produce more energy as compared to a petrol, so most of the loading trucks or buses or lorries, their all engines are working on the diesel. Then the remaining fractions will rise. Another fraction which condense here, that is called kerosene, or we can also say paraffin. Kerosene or paraffin oil is there, that is used by aircraft. So this is used as an aircraft fuel, the paraffin. Then the remaining fraction will rise and condenses. Then we have a naphtha. Naphtha is making different chemicals. It is used in petrochemical industry. So different chemicals, the main raw material is a naphtha. Then the remaining fraction will rise. That is gasoline or petrol, that is used for car. The fuel which we use for the car, that is known as the gasoline, and it is also known as octane. Octane means, oct means 8 carbon and 8 means there's a single bond. There are a single bond between the carbon atoms. So between the carbon atoms, they have a single bond, and oct means 8 carbon atoms, and it is having a name known as petrol or gasoline. And remaining, some of the fractions does not convert into liquid, they don't condense. So we use them as a bottle gas. like we are using as a, or we can also say a domestic gas, which we use for cooking, for camping, we use this gas. Mainly it consists of propane and butane. So the crude oil which we obtain here is a mixture. A crude oil, what it contains? It consists of bitumen, fuel oil, diesel, kerosene, naphtha, gasoline, and refinery gases. So different substances are present in the crude oil. Then when we compare the number of the carbon atoms, remember the number of the carbon atoms at the boiling point is directly proportional. If a hydrocarbon contains more carbon atoms, it will have a high boiling point. So the fractions which we obtain at the bottom of this fractionating column, they are large molecule. Large molecules mean many carbon atoms are there. That's why they have high boiling point. And they will have low volatility. Volatility, it's like converting to vapor. If something easily convert into vapor, we call it is more volatile. But because if a substance is having a high boiling point, so it will be less volatile. They does not flow easily because there are like thick viscous liquids are there, does not flow, and they don't easily ignite, does not burn easily. But when we check the fractions which we obtain at the top, there are small molecules, so they will have low boiling point, and boiling point and volatility are inverse. If the boiling point is higher, then volatility will be lower. If boiling point is lower, then volatility will be higher. And they can flow easily because few carbon atoms are there, and we can also burn them easily. But because if why, even though bottle gas can burn easily, but we don't use for a aircraft fuel, because if it can burn easily, but it does not produce lot of energy. When we burn these hydrocarbons compounds which are having more carbon, they can produce more energy as compared to compound with few carbon atoms. Is it clear? The fractional distillation of a crude oil and the name of the fractions which we obtain. So you have to learn the name of the fraction, the order as well, along with their uses. Then, as I mentioned, because the lower fractions are easy to burn as compared to heavy fraction. So we want to convert these lower fractions, the heavy fraction into lower fraction. So how to convert the heavy fraction? Heavy means like large molecule into the small molecule. So the technique which we use to convert the large molecule into small molecule, we call that as cracking. So cracking is a process when large or long chain molecule converted into small molecules. So when we crack a hydrocarbon, then there are two possibilities. It might produce alkane or alkene, or it might produce alkene or hydrogen. So cracking is a process by which we break a large molecule into a smaller one. And cracking, what it can produce? So process of converting the large molecule into small molecules, we call that as cracking. So what are the products? What could be the product? If we have a large molecule, there are two possible products are there. If you have a large molecule, what might be one of the product? It might produce alkane. When we crack, it might produce alkane, all like carbon atoms with a single bond, and alkene. This is one possibility. Or the second possibility, the large molecule, when we do cracking, we break down, so it might produce alkene and hydrogen. So these are the two possible products which we can obtain when we are cracking. But how to identify, how you will identify whether a compound is alkane or alkene? So you can identify the compound by using a simple formula. If a compound is an alkane, then the general formula of alkane is, if the product is alkene, the general formula of alkane is CnH2n plus 2. What does it mean? It means the number of the hydrogen will be twice as compared to number of the carbon plus 2. And if it is an alkene, I'll give an example for both. If it's an alkene, the number of the general formula is CnH2n. It means the number of the hydrogen will always be twice as compared to number of carbon. So if I say I want to write a formula for propane. So prop means what? Prop means value of N is equals to 3 carbon atoms. So if I use this journal formula, so according to this journal formula, it is C3 because N is equals to 3. So C3H 2 multiplied by 3, 6 plus 2. So it will become C3 2 multiplied by 3, 6 plus 2, that will make 8. So the formula of the alkane or propane, that is C3H8. So you can see the number of the hydrogen are twice plus 2 the number of the carbon. But if I want to write a formula for propene, so when we write a formula for propene, prop means again 3 carbon, but because it's an ene, alkene is there, so the journal formula is CnH2n. Number of hydrogen are twice as compared to number of carbon. So C3 and H2 into 3. So when we substitute C3 and 2 multiplied by 3, 6. So C3H6, that is the molecular formula of this compound. So if a compound is an alkene, number of hydrogen will be twice as compared to number of carbon. But if compound is an alkane, the number of the hydrogen will be twice plus 2. Another example, if I say butane. So but means N is equals to 4. So if we substitute, because it's an N, so the general formula is CnH2n plus 2. So it will be C4H 2 multiplied by 4 plus 2. So when we simplify C4, 4 multiplied by 2, 8 plus 2, so 10. C4H10. That's a formula for butane. But if I want to write for butene, but means N is equals to 4. So it will be C4H 2 multiplied by 4. So C4 and H8. So the number of the hydrogen in alkene will always be twice as compared to number of carbon atoms. Whereas number of hydrogen in alkane will be twice plus 2. So this is a journal formula to remember about alkane and alkene. So if a compound is alkane, what is the journal formula? That is Cn H2n plus 2. So when we write for any alkane, this is Cn H2n plus 2. So any alkane is given by this formula. And if a compound is alkene, this is Cn H2n. So if we say I want to write a formula for ethane. So eth means what? Eth means how many carbon? Eth. Yesterday we did this. The prefixes eth means how many carbon atoms? Yeah, that's right, Mohammed. H means two carbon atoms. So N is equals to 2. So it will be C2H 2 multiplied by 2, 4 plus 2. Uh, so it will be C2 and H 2 multiplied by 2, 4 plus 2, 6. So the formula for ethane is C2H6. And if we want to write a formula for ethene, ethene, so eth means what? 2 carbon. N is equals to 2. But because it's an ene means the general formula CnH2n. So number of the hydrogen are always twice as compared to number of the carbon. So if we substitute the value of N is equals to 2, so it will be C2 and H2 multiplied by 2 because in place of N we put 2. So it becomes C2 and H4. The general formula of alkene, the number of the hydrogen is always twice as compared to carbon, but in alkanes the number of the hydrogen are twice plus 2. So when we do a cracking of a hydrocarbon, cracking means when we break down the large molecule into a lighter one. So what are the possibilities? It might produce alkane and alkene, or it might produce alkene or hydrogen. So example, if the molecule was say C8 and the large molecule means like so many carbon atoms are there, so C8 and H18. Now I want to complete a product. Here we can write any number. So example, if I write C5, because I want to make an alkane. So how many hydrogen should be there? If I want to make an alkane. For alkane, the number of the hydrogen is always twice plus 2. So what is twice of 5? 5 multiplied by 2, that is 10. And 10 plus 2, 12. So it will be C5H12. It will become alkane. And in the beginning, we were having 8 carbon. I use 5 carbon here. So how many carbon I'm left with? I'm only left with 3 carbon because the total carbon on the left hand side should be equal to total carbon on the right hand side. So if I use 5 carbon here, then I'm left with only 3 carbon. And I want to make alkene. So if you want to make an alkene, this is for alkane. If you want to make an alkene, the number of the hydrogen are always twice as compared to number of the carbon. So if there are 3 carbon, then how many hydrogen should be there? Because these are hydrocarbon and hydrocarbon only contain carbon and hydrogen. So C3 and H6 will be there. So this is how we completed a product for cracking. So whenever we crack a hydrocarbon, this is one possibility that it might produce alkene or an alkane. Another example, and the number you can select any number. It is not fixed. It's up to you. Any number you can select which one you want to break. Like if another example, if I say I have C10 and H22. I want to produce alkane. There are 10 carbon atoms, so I can select any number below 10. I can select, example, I select 7. So C7. To be an alkane, how many hydrogen should be here? If I want to make an alkane. Yeah, that's good. Because 7 multiplied by 2, 14, and 14 plus 2, that will make 16. So it will be C7 and H16. Plus, because out of 10, I use 7 carbon. How many carbon I'm left with? 3. So if I'm left with 3 carbon, then because I want to produce another product as alkene, and to be an alkene, the number of the hydrogen should be twice. So what is double of 3? 3 multiplied by 2, that is 6. So it will produce C3H6. Another example, if I'm cracking C9H20. And one produce alkane And any alkane you can select. Example, I select C4. If I select C4, how many hydrogen this alkane should have? The alkane, the number of the hydrogen should be twice plus 2. So twice plus 2, 4 multiplied by 2, 8, and then plus 2, that make 10. Yeah, that's right. Plus, out of 9, I used 4 here. How many I'm left? So I'm left with 5. So C5. Because out of 9, I use 4 here. So I'm left with 5 carbon. Now this will have how many hydrogen? So because it's an alkene, so the number of the hydrogen should be twice. So 5 multiplied by 2, that will make 10. So it will be C5 and H, 10 will be there. Another example, if I say I have say C12 and H26 and I want to do cracking. So any alkane I can select here, it's not fixed. I can select any of them. Example, I select C8. If I select C8, carbon, 8 carbon, how many hydrogen should be there to be an alkane? So 8 multiplied by 2 is 16 and 16 plus 2, 18. So C8H18 plus out of 12, I use 8 carbon here. So I'm left with 4. So C4. And how many hydrogen? Because the number of the hydrogen should be twice compared to carbon in alkenes. So if there are 4 carbon, how many hydrogen I should write? 4 multiplied by 2, 8. So C4H8 will be the product. So whenever we are breaking a large molecule into a smaller fragments, smaller molecules, we call this technique or the process is cracking. And what is the one of the product the cracking can produce? The cracking can produce alkane or and alkene. If it is producing an alkane, the journal formula should be CN H2N plus 2. If it produces an alkene, the journal formula should be CN H2N. Is it clear, this part? So converting the long chain molecule into smaller one, this process is refers to cracking. Then homologous series and isomerism. What is the concept of a homologous series? A homologous series, like a family of organic compound, is called a homologous series, and which is this is having a following characteristic. Like when we talk about alkane, alkane is one of the homologous series, like one of the family. Alkane means between the carbon atom there should be a single bond. And what are, if I draw the structure of first 4, so this is methane, ethane, eth means 2 carbon, and ane they have a single bond. Then 3 carbon propane, and 4 carbon, 1 2 3 4, butane. Now when we write the molecular formula, 1 carbon, 4 hydrogen, 2 carbon, 6 hydrogen, C2H6, 3 carbon, 8 hydrogen, and 4 carbon, 10 hydrogen. Now which which series is known as a homologous series? Number one, there should be a following characteristic. If the following characteristic is fulfilled, we call that as a homologous series. So what are the characteristics to be a homologous series, or the properties of the homologous series? Number one, there should be a general formula. Like there should be a formula which we can use to find any of the member. So there should be a general formula. So when we check, alkanes have a general formula. What is the general formula of alkane? The general formula is CnH2n plus 2. Alkanes have a general formula. That's why it follows the first property. Now what is the second property to be a homologous series? Each member differ by CH2. Means the difference between the each member should be CH2. Now when we check the difference between the members, this is having CH4, C2, H6. So what is the difference between them? Like how many carbon atoms and how many hydrogen atoms are different? Like this is having one extra carbon and two extra hydrogen, so CH2. Then the next member, C2H6 and C3H8. The next member is, when we check the difference, one carbon is different, like one carbon different and two hydrogen different. When we check another member, one carbon different and two hydrogen. So it also follows the second property, that each member differ by CH2. Then what about the third property? The third property, they should have a same chemical properties. And that about the chemical properties we will discuss later in this chapter, that about alkane, when we write their chemical properties, you will find that they all have the same chemical property, same they will react. And the last property, the physical properties gradually changes, slightly changes. Physical properties such as the boiling point, melting point, these are the physical properties, the state. So the physical properties of these members should slightly change, like they should have a difference, but very small differences there. So when we check this, we will find that when we find the boiling points, this is gradual change. And the boiling point increases as the number of the carbon increase. More carbon, as number of the carbon increase, the boiling point will also increase. So if we have these four members of alkanes, the first one is methane, meth because of one carbon, and ane because of single bond. The second one is ethane, eth because of two carbon, and ane due to single bond. The third one is propane, prop because of three carbon, and ane due to single bond. And the fourth one is butane, but because of four carbon, and ane because they have a single bond. So we have, when we check these members, methane, ethane, propane, and butane, we will find that each member have a difference of CH2. The physical properties gradually changes, chemical properties are same, and they have a general formula. So what we can say alkane is a homologous series, because alkane follow all the properties, that it is having a general formula, each member differ by CH2, the chemical properties also are similar, and physical properties gradually changes. So we say alkane is homologous series. So for a compound, for a group of or a family to be a homologous, like alkane is one family of a hydrocarbon which are having a single bond. So to be a homologous, it should follow the characteristic, and because it is following these characteristics, that's why we call this as a homologous series. Is it clear the reason why alkane is referred to as homologous series? Because it follow all the characteristics. So same way, if we want to check alkene is homologous or no, so we will find alkene is also a homologous, because in alkene, to identify whether alkene is homologous, alkene does not, it started with C2, the first member is C2H4, the second member is C3H6, the third member is C4H8, the fourth member is C5 and H10. They have a general formula CnH2n. So when we apply all the characteristics, like these are the characteristics or the properties of a homologous. So when we try to apply these properties on alkene, so first thing, there should be a general formula. So they all have a general formula, like there's a general formula for alkene, which is CnH2n. That is, each member differ by CH2. So when we check the difference between the two members, next member, like two carbon, three carbons, so one carbon is different and two hydrogens are different. Like two extra hydrogen and one extra carbon. This also one extra carbon and two extra hydrogens. This also one extra carbon and two extra hydrogens. So each member differ by CH2. Later we'll discuss their chemical properties and the physical properties. We will find that gradually changes, slightly changes, but the chemical properties are identical. So alkane, because it fulfill all the properties, so alkene is also a homologous. So alkane and alkenes both are homologous because they follow the characteristics. Then what is the concept of isomer? Isomer means compound with the same molecular formula but different structure. So if we have compound, they have the same molecular formula but different structure, we call them as isomers. So example, if I want to draw an isomer, so same molecular formula but different structure, what we call isomer. Like example, if I say I have C4 and H10. So C4H10, because number of the hydrogen are twice, so this is an twice plus 2, so this is an alkane. So four carbon atoms, how I can draw these four carbon atoms? I can draw in line 1, 2, 3, 4. And then I put hydrogen. So this will, because alkane is there, so they all have a single bond. This will have 3 hydrogen. This will have 2 hydrogen because carbon maximum can form 4 bond. This will have 2 hydrogen and this will have 3 hydrogen. This is one way. What else I can do? I can draw 3 carbon in a line and one as a branch. This is called a branch, up or down. It's up to us. We can draw up, we can draw down. So now I complete this structure because it is an alkane. So between the carbon atom, there should be a single bond. How many hydrogen this will have? Because one bond is shared. So this will have 3. How many hydrogen this will have? Only 1. How many hydrogen this will have? 3. And how many hydrogen this will have? Also 3. So when we count the number of the carbon atom, 4, number of hydrogen 10. Number of the carbon atom 4, number of hydrogen 10. So two compounds have the same molecular formula, the molecule number of the atoms are same, but they have the different structure. What we call them? We call them as isomer. So isomers refers to the same compounds with the same molecular formulas, but they have different structures. Is it clear the definition of isotope? I'll give more examples. Less than a minute left, so I'll share another link.